Cool, thanks guys. You can hear me okay. All right. Yeah, so good morning. I'm really excited to be speaking at JSConf. I've never really spoken at a conference before, or at least one with, thanks. So, yeah, and it's really exciting because in 2015, Patricia Garcia gave a talk here in Berlin at JSConf on offline first data. And I wasn't there for it, but I saw it a year or two later on YouTube and kind of figured out where her LinkedIn profile was. There was no job, so I found her GitHub profile, and I found a link to a repo at Justin's organization, which is Field Intelligence, where I work now. So I emailed Justin, and 2 weeks later, I was on a plane to Nigeria, and now Patricia and I are colleagues, and I'm speaking here about offline first stuff. So the work we do is in trying to deliver healthcare commodities where it's a bit tougher to deliver them, expanding access with partnering with federal governments and with down to small pharmacy traders, and doing that with software, supply chain software. So we're headquartered in Abuja, where we work. It's in the middle of just below the red part in Nigeria. And this map is population. And kind of one of the reasons why Nigeria is because it's huge and it's growing like crazy. It has a massive market, and it's like about 1/6 of the continent, like 200 million people. We're a small team of software developers, operations people. We have an office there, a small one here in Berlin, and then a couple operations offices in Lagos and in Nairobi. So 3 years ago, or 4 years ago when the company started, you kind of asked the question, okay, what tech stack are we going to use for pharmacy supply chain management? You can buy one. You can use one that's already built. There's a lot of them. You can customize on top of a development platform like an Oracle or an SAP. A lot of warehouses and places in Nigeria do this. Or you do what a lot of large companies do, a lot of large tech companies and Fortune 500 companies, where they just build their own. And if you're going to do that, and it's 2015, 2016, you're probably going to choose like a very boring but sensible stack, maybe something like C#, .NET, or Django with Python, or Ruby on Rails, something with a Postgres or some sort of SQL relational backend, which works really nice with enterprise resource planning. You get a lot of stuff out of the box, a lot of tools that can really help you. But for us, our requirements were a lot different than that. And the contrast that I kind of like to invent, people will talk about these cities in different ways, but I like to think of Abuja and Lagos as the two places we need to operate. And Lagos, for people who have been there, is a mega city. It's like a country. It's 20 million people. It has tons of growth, tons of money, tons of opportunities, and then it also has networks that sometimes work and sometimes don't work. You're a small pharmacy, you connect to the internet on a cell tower. There's tons of cell towers, you see them everywhere, but then there's a traffic jam right outside of your business, and suddenly 10,000 people are trying to use the same cell tower, and you don't have network, but you need to keep working. And then Abuja is a planned administrative city of just like 1 million people. And I always have internet there. People don't carry cash, they pay with bank cards. Our partners at the federal government have this giant command center room that has network, it has HD TVs, it has a rotating web camera that follows you as you talk, and they need to see what's going on in the whole country. So we want to make something that's better than just a traditional boring web application. We need something that can work in both of these places. And so that means doing something that's offline capable. And offline is not binary. It's an offline capable app or it's an online app. You have, oh, it looks crazy on the screen. You have like a lot of different options. The first one is what we call small offline. These are names we made up for these categories. And it's kind of like a marketing gimmick that a lot of web-based apps use where they say we're offline capable. And people who aren't software developers don't know what that means. But like we know what this means. It's like kind of like you're working on an issue ticket in GitHub and you lose network connectivity. You can like keep typing. The data will stay there. Maybe it's thrown into local storage, but you don't want to like refresh. You don't want to click around. So we couldn't use this model. It's not going to work for us. Medium offline, which is our word for like just using a native app, like an iPhone app, an Android app, or writing for a like Windows or Mac OS, is a lot more attractive. And I've done work on apps like that before for pharmacy supply chain. Our company has as well. And it's not something that we're necessarily going to rule out in the future, but it is still very manual. There's question marks for how offline it is, because it totally depends on you as a developer. What kind of database are you working with? What rules are you setting up? And how are you syncing with remote? So like the example is like you pay to have offline features in consumer apps like Spotify and like Duolingo that give you offline features that Duolingo seems to work really well, but like Spotify's, it seems like every time I get on a plane, it forgets what I said to download offline. Big offline is really important to think about because this is how hospital IT systems work, most of them historically. This is changing, but what you've had over the past couple decades is, excuse me, like a very large on-site deployment of servers, even a server warehouse. You have IT staff, you have a local area network. And it's because clinicians need their software to work offline. It's not like offline is new to tech companies in this industry. But as I said, like that's not going to work for us. We can't put a server in, like right now we're working with about 30,000 pharmacies, and there's hundreds of thousands to plan for. So we went with the web, with offline first in the web. That gets us kind of the things we want, low IT support, you can do the whole thing offline, but it's still the internet, it's still syncing. And there's a lot of talks on which distributed database to use. Like the basic setup for an offline app, web app, is you put a service worker in, you tell it to cache the static application, and then you work with local storage in the browser, which has become a lot more attractive over the last several years. You get to use a lot of the user's available disk space, a percentage of it. But how do you work with the in-browser database, and what do you replicate with? And CouchDB and PouchDB, which some people at this conference helped build, are kind of like the tools that most people end up using. We're really happy with the area that they cover for us. If you know of some cool tool that somebody has, or like this question that I often get is like, oh, why don't you just write your own super cool like replicating thing that uses blockchain and Kafka and is event sourced. And the thing is that like with these two, our problem is never in the actual replication protocol. We don't have engineers sitting around wasting time trying to figure out what steps went wrong. If there's a little bit of network, the documents sync. So these two have been really useful for that. Like somebody gave a talk a while ago where they said friends don't let friends build their own replication protocols. Gregor said this. And yeah, all of our problems are elsewhere. We have our stack, we're sticking with it, and like what could go wrong with this somewhat non-traditional application? And for those of you who've maybe done work in like global public health, you know that it's not actually this very well, clearly administered, highly educated system of people with clear incentives. Like it's constantly in a state of emergency. The whatever the current situation is, or however the current administrations are working, there's just this constant need to build things quickly and make things happen, and very sort of unclear incentives. It's not like a market economy that's just working off of a bottom line dollar. So we started hitting like a lot of problems right away. Even though all of us had experience in building these kinds of applications, we were building them at a very much bigger scale than what we'd done before. And the first problem you hit right away is, what do you sync? You have to segment the data somehow. You can't, I mean, we started by just giving all of the data to every client. We say like, you get the whole database. But then over time, you need to start segmenting on something. Because if it's all gonna get stored in the user's browser, it doesn't matter how much space they have. The data is growing linearly over time. We're getting hundreds of thousands of documents of reports and shipments. So you can't just tell the user, take everything. And the way you segment data using these databases, using CouchDB, is you set up a partition per a user. You say, this user is going to get these documents. And the way you get it from the main database is you just sync them. So your rules for setting this up are just entirely custom code. It's entirely up to you. So you have to take into consideration, all right, what are our rules? We need to, somebody in Delta State should not be seeing the same data as somebody in Lagos State. Okay, cool, geography. Next, time. Time-based data becomes a really big issue because you need to sync some of it, but not all of it. But then this comes into like the domain model of what is okay to cut off. Because like to calculate how much stuff you have at a store or how much money you have in your bank account, it's usually like, what was the opening transaction? And then let's add all of the debits and credits over time until I get the current balance. But if I only sync your last 10 transactions, that's not going to give you the right data to get the right end number. So you look at what to sync as a developer, and you have all of these different choices. The other thing that I'm not going to spend a lot of time on is that with supply chain management, you have really crazy access rules. You have tons of dynamic lists of who's allowed to see which certain sponsored commodities at which certain locations 2 years ago at this month. So there's not like a ton of, really clear ways to model your data. Next is network storage, and this is kind of exciting. Normally in an application, you have a database that you're working with. And so your code to access the data is just in one place. And you try and keep it abstracted. Maybe someday you're going to re-platform and you're going to choose a different database. But typically you're working from one type of data store if we had gone the traditional like web framework application. And with online offline, you have data that can be coming from the IndexedDB browser database through Pouch. You have data that could just be like in an in-memory, cache. You have requests from the browser to get remote data that you don't have locally. And then you have back-end serverless functions that are also talking to the same database that need to do similar business logic. So developers don't really have a framework for where we're busy, we need to throw our code somewhere. If this was Rails, I'd have an endpoint, I'd have a new table, I'd set up a new entity, and I'd put the code under it, and even if it's messy, everybody in the organization is used to that pattern. But for us, it was just like, just put it wherever you want. Like, let's put it in the Lambda, let's put it in this backend script, let's put it in the front end, and then over time, you don't have like an isolated place because you're working with different network storage adapters. One of the bigger problems that isn't just us on the front end doing web-based applications is modeling JSON, modeling sort of without a relational database. And there isn't, as far as we know so far, like there isn't one clear way to do this that always wins. There's a lot of different strategies to deal with the problems. So normalization, like you want this table and this table and this table to be neatly separated, and you have foreign keys between them. Like, this is a database, that's awesome, that's what you want. And so you're a developer and you're like, I'm gonna do this in JSON. So I'm gonna create a document and a document and a document and a document. And then to get this document and to join on them, you're making HTTP requests over a network because you don't know what the relation is yet. So then you say, oh, okay, that's too much. I'm gonna put everything in the JSON document. And then a user says, hey, we need to change the name of this item. You say, okay, let me just do a bulk update on half a gig of data and hope that there aren't any conflicts. So, and it's not always clear what the right strategy is for this. Sometimes it helps to denormalize, sometimes it helps to normalize. And document conflicts, Patricia Garcia's talk had some really cool in-depth details about strategies for using multiple documents to have two users working on the same entity at the same time without causing conflicts. So yeah, and then the other one is like around what you sync to who, so like kind of access stuff. You might have a list of pharmacy commodities that you need to send to a supplier, but it turns out there's two suppliers, one for cold chain commodities, one for non-cold chain commodities. So you need to split the document. So it's like a business rule that impacts how you're modeling the JSON, and when a user says, hey, I need to make a new type of database table, you know, couch people, what do I do? You say like, it really depends on what you're doing. So it makes having a single framework for everything difficult. So deciding how to segment data and what to sync to users, we created this thing we call an ID dispenser. And it's just a remote endpoint that when a user starts and they initialize the application, we have the browser make a call to a Lambda, and the Lambda takes the user, who it is, what their location is, what programs they have access to, and it goes and it talks to CouchDB, and it says, hey, what documents does this user need? Couch says, okay, based on your business logic, it's X, Y, and Z. Lambda says, thanks, sends it to the browser, and then the user has a subset of the data that they get to use. And as an aside, like, this has so far been working for us, but if you're gonna use like infinitely scalable serverless functions on behalf of clients, remember that other resources of yours are not infinitely scalable, and you might DDoS your own database. So yeah, this is really exciting. Like, what we've started to do in our APIs with this problem of sometimes your network storage adapter is a local database, sometimes it's a remote database, sometimes you're a node, is having APIs that have all of that defined in them per entity. It's one API that we use in all of our different places, in Lambdas in the back end and on the front end in scripts, and your API can know what kind of network storage adapter you're using. So you have situations where you ask, hey, give me all of the reports, and the API goes, okay, cool, I'm looking in the database, I have found 3 months worth of reports, and that's what I know about that's offline. And the user then says, but I want a page back further than that. This isn't fair that I should only see what's offline. And the API at that point says, I'm gonna switch network storage adapters and I'm gonna go fetch the remote docs and give that to you. And then a lot of this ties back into, like, how do you design this kind of application for the user? You have to tell the user what's going on. If they look for a report on their facility, some facility that's remote, maybe they don't submit reports that often, and they want to know, has this report been submitted? And they're working offline. The ID dispenser told them, you should know about this range of documents. You should have these offline. So if you go and check and the document's not there, display to the user, this thing doesn't exist. I don't care about what's on the remote. I know that this document was just never submitted in the first place, or that it's there. Then, if you're going too far back to a segment of the data that we can't sync, something that's much older, we tell the user and we display in the UI, like, this has got to be an online resource. This is something that you're not going to have offline. So if you have network, you make the remote call, comes back, says, yep, we don't know about that report. Or, yep, here's the report, display it. But if you're offline, you have to display to the user, hey, like, we don't know. Like, we're offline. We don't know if this report exists or if it doesn't exist. So, yeah, the last thing is some pictures where this is like a remote clinic that has a pharmacy. And you can see there's like a little bit of a VSAT, which is for satellite internet. And this clinic had pretty good internet at the time. It was like 2014, and they had like 12 kilobits a second down. And that was fine. Like, they could have an application on site on a laptop and dispense point of care to patients. So as patients would come up, still for the supply chain, not for the clinicians necessarily, but you would track the movement of pharmaceuticals electronically. And so when you're designing for this place, you think, well, hey, we can just use a network. We'll just really make sure that that VSAT always works. We'll talk to the IT team. We'll be really serious about it. But that's not the case. This VSAT would very frequently get slightly misaligned, and the clinic would lose internet. And what's really kind of the point of using this somewhat difficult and non-traditional application is that for that pharmacy, like, it didn't matter. The application worked fine. It continued to work. They could create patients. They could create dispenses. They could look up their stock. They could transfer stock internally. And then, I should show the pharmacy. The pharmacy is like that one in the back. They're all red and look the same. But the cool part was that when a shipment would come once a month from the central warehouse, what would you do? You would have to manually enter that like you're using an offline system. And then also worse is that you have hundreds and hundreds of transactions daily about really important commodities that the central team needs to plan and think about. That's why they asked us programmers to build something. So if you're not going to send that data back home, then it's like, why are you tracking it in the first place? Unless it's something later, some analysis or something, which is what a lot of systems end up being used for. So what the team would do is they would walk to this river, and I like this photo because it looks really nice. But this river was like really directly behind the pharmacy. It's like just less than a kilometer. And there's a cell tower over there now that when you're at the river and you have a cell phone and you're tethering to your laptop, you have fine connectivity. And they didn't really do this every day. They didn't need to, but they could just go over there whenever a shipment would come. They would learn from the remote about the shipment. It would update their inventory levels, and then they would sync to the central server and the central team. These are all the commodities we dispensed over the last couple of weeks, and the central team could see, oh, hey, cool, they need more of this. They're good on that, and we can know what to do next, even though their VSAT is misaligned and the IT team is busy. So yeah, that's kind of like it's really exciting work. Like, we have to know a lot about JavaScript, and we have to do new things and try and talk our own team and our own selves into trying to use patterns and put code in the right place. So it can feel really frustrating. And at times, many times, we will kind of look at each other and be like, what are we even doing? Like, why don't we just make a Rails app or a Django app? Like, this is so hard. But like, ultimately, it means an application that is more like robust. Like, it can get us more data and it can work in the places we want to work in. So even though like a year or two ago it was looking pretty scary, there's been a lot of learnings from us about stuff we've done wrong that have made it possible to kind of safely start delivering this type of application at a pretty large scale. So I'm out of time. But thanks very much, guys, for your time, and I was happy to talk here today.